Hello everybody and welcome to our chapter 2 Python Basics lecture recap. So in today's lecture, I'd like to recap some of the more important parts of the lecture that I've done a couple of weeks ago. So what I'd like to do today is to quickly skim through the Jupyter notebook and show you what are the important parts that you can slow down and carefully absorb, because it's on video anyway, so it'll give you some time to process the content of the lecture at any given speed that you like, because we have this video on YouTube, right? Therefore, feel free to speed up the video at 1.5 times if you feel like I'm speaking too slowly, or if I'm speaking too fast, you can probably slash the playback time into half. Okay, so I'm not going to go through the setting up of the environment and installation of Anaconda, because there's a lot of YouTube videos online for that. However, if you're still struggling with the installation of Anaconda, please do let me know through WhatsApp or through Schoology, because I'll be more than happy to assist you in the installation in your given device. So in today's device, I'm actually using a device that's not my laptop, so I can't really show you how to create a new file, right? Because here, to create a new Jupyter notebook, navigate to a folder of your choice and select new Python 3 from the top right hand of the screen. Right, usually you'll be able to do this here. However, in today's lecture, I won't be showing you that. It's okay. So what you'll be able to do is you can download the chapter 2 students version, and then I'd like you to code along with me, right? So in today's Jupyter notebook, I've also edited some parts so that we can type together, right? So treat this video as like a code along that you can join in whenever you like, right? So how to use Jupyter notebooks? We are inside a Jupyter notebook now, and then I have provided you the Jupyter notebook so that you can code inside. All right. Okay, so today one of the earlier steps of using Python is actually the ability for you to print out certain things using the syntax print and then putting it in parentheses. So like today is my first time coding in Python. Well, not really, because I think you've coded before in Python. Right, so let's add another one. To add a new code block, we can press this. Or you can just press Ctrl B. Okay, surprisingly it doesn't work here. It's okay. But either way, you can add the other code blocks by pressing on this plus icon here. So let's print another statement here. Print. What is it that you like? Print. Have a good day ahead. Right? So once you're done with that, print and then putting in putting the text or string inside, starting with round brackets, and then you have the double quotation marks. Actually, do note that you can also do this with single quotation marks, right? Have a good day ahead. So when you press run, right, it's going to run the code block for you, okay? So to prove my point, you can also use a single quotation mark and say I am doing well. I'm doing fine, thank you. I am fine, thank you for asking. So let's run this and see. Okay, so we can see that the print syntax, it does work with double quotation marks or single quotation marks. Okay, so Jupyter is a notebook environment which allows us to write codes inside of cells. So in square brackets 18, this means that this is indeed the 18th code cell that I've run inside this Jupyter notebook for this time around. Okay, so as I press run every time, it adds the number, right? So this means I have run 20 code cells for this session. Okay, so you can see here, like in this notation, in these notes, you can see what every single tab means. You have the you have the directives for showing what the file menu does, what the edit menu does, what the view menu does. So feel free to read and peruse all of these sentences as you say, as you can, yeah, at your own time, right? Because you're here actually to code along with me, right? So I trust that you will be reading on this in your own time. Okay, so some of these things, what is the difference between a markdown and a code, right, is because when we are writing code, the type of the code cell can be changed interchangeably. So this one, if you're running code here, right, the type of the code cell is classified as code. However, the beauty of Jupyter Notebook is that you can also save notes, right, in which you can actually change it to Markdown. So Markdown allows you to write some notes in association with the code cells that is contained above or below the code cell that you have worked with. So like here, I think this Jupyter notebook would be a lot emptier if I didn't put in the notes which are included inside of the textbook that we're using. So basically all of the notes that I've written here has been painstakingly, yeah, it has been typed out every single one of these words. I have typed every single one of these words, so hopefully it helps, right? So you would actually do me a favor by actually reading it, yeah? So don't worry if you feel like the markdown. You must be wondering why my markdowns are a little bit different than yours. Because if you double click on the markdown, you can see that I've done some formatting on it so that it looks a little bit easier on the eyes for readability. Okay, so you would see that the formatting is actually following the HTML formatting, but then it's okay. Formatting in Markdown isn't actually a part of a syllabus, but also I hope it helps with your studying because it looks better on the eyes, I think. Yeah. So Markdown is a typesetting language used to format your notebook. A well-formatted notebook has code type cells and Markdown type cells. So like I can say previously, we have the code blocks and then we have the markdowns which describe the code blocks themselves, code cells. Okay, so a little bit of fun we can do with Python is actually we can insert images, right? So this is what I feel like how civil engineering students feel about programming. Well, most of civil engineering students anyway. Because most civil engineering students, they come into civil engineering thinking that they won't have to do any coding, but hey, surprise, you actually do have to. Okay, so when you double click on this, right, you can see that this is actually an HTML formatting of me getting the image from the internet, right? So when I run this, I have this picture imported directly from a given website. So this was the famous meme back in 2019, and surprise, we're in 2021, but in 2021 or 2020, let us update the meme. So here we have Mercedes-Benz started with this because the most famous meme last year was surprisingly not really related to the pandemic, but actually but how it started and how it's going. So a little bit of levity in a very serious time where everything is a little bit too serious. So I hope, yeah. So here the title is Mercedes glowed up. Forgive me for using Gen Z references, but I do hope you appreciate my effort trying to connect with my younger audience. Okay, so this is how you insert an image inside of a Jupyter notebook. You use the line here, IMG SRC. Okay, so this is not really a part of our syllabus, but I I think that you'd appreciate me what do you say, explaining some of the stuff anyway. So I'm using the HTML style of annotation. So make sure that the code block is actually marked down. All right. Then you insert the address here. Okay. So you have the alternate title or the actual title here. So when we run this, right, you get this displayed in your code block. It's very nice. Okay, so in the following sections, we can start to explore the functionalities that Python offers to its users. Okay, so if you don't want to hear the start of the lecture, so actually here is when the real lecture starts. Just now it was just me trying to show what Python is capable of doing in so many ways. Okay, so here goes Python syntax. So just now I showed you how to print out statements, right? Print hello world. So hello world is actually an inside, I wouldn't say joke, but then it's a commonly used phrase for first time coders in any language. So I first encountered hello world when I was learning my first language, which was C++, and thankfully I have made the jump to Python, right? So Python is a little bit closer to the English language in terms of the syntax or the way that we write code, right? It's a little bit closer to spoken English. You don't have as many, you know, semicolons and whatnot in order for you to indicate that the code has finished. Right, in Python, the way that you show that a line is finished is when you leave a space after a given code, right? It doesn't really need to be accompanied. Say, for example, if you are coming from C++, usually C++ users will be accustomed to the lines ending with a semicolon. However, that's not the case in Python, so don't worry. Okay. So anyway, I'm digressing. So back to our lecture. A comment is actually used for programmers to speak to each other or to for the coder to be able to recognize what each line does. Right, so you have single line comments and you have multiple line comments. So they use the comment and explain what the code does in order to keep everything as clear as possible. This is essentially very necessary because when you're writing code, and sometimes when your code gets passed to a colleague, right? Your colleague would want to know, hey, what's going on here in this code cell? So what you would do is actually you would do some notation on your written code so that the other party or your colleague would be able to find out, oh, okay, so this is what it does. So you can either do it on either single line comment or a multi-line comment. Okay, so a single line comment uses a single hashtag. So like, for example, if you want to say, oh, sorry, this code is written for the triangle formula. Okay, so in certain cases where you feel like the function or a given code style is a little bit more complex and then you need more than one line of comment, feel free to use the multi-line comment, which is actually essentially three single quotation marks in a row, and then it's nested with another set of three singular quotation marks. 1, 2, 3 ABC. 1, 2, 3. So normally if you're using a laptop or a PC, right, this Jupyter would automatically do the auto completion for you. But I'm running this on a Pydroid, so it doesn't really show up automatically. So in a sense, this is better for me because it helps me with my coding skills. Normally, when the coder is accustomed to auto completion, it doesn't really polish their skill because you're relying on the machine to correct your code. So in a sense, this is helping me get better. So I would know exactly how many quotation marks or how many parentheses, square or round ones that I'm actually using, right? So yeah, I highly recommend using Pydroid. So you can see here that just now there's a pop-up that shows notebook saved. So please feel free to save your notebook every now and then. Okay, so multiple BR. Okay, so actually BR is breaking of the line to an entirely new line. And then this \n and \n actually shows you that the line, this line here, is actually written in such a way that it starts on a new line. So you have 1, 2, and 3 new lines here. So which is why after the multiple and then you have the break, you have one new line here, one new line here, and another new line here. So it's multiple lines, just to show you that actually the multi-line comment can be broken up into new lines. Okay, so enough about comments. Let's go into variables and data types. So variables are containers in which you can store values. Okay, the main types of data structures that are built in Python and that can be used without loading any library are, you have the integer, which is denoted by int. You have float, which allows you to use floating point numbers. And you have bool, which are boolean type values. A boolean can be true or false. Okay, so that's just two outcomes. And then we have string, which we have seen earlier on, like hello world, and then like this is my first time coding Python. That is actually a string, which is a sequence of characters. We have a list, which is Python's built-in arrays, which we will create later. We will see dictionaries, which are a little bit like this, but it's a little bit more advanced. And then last but not least, tuples. Right, so here goes. Integer numbers are numbers that you can use the what do you say, operational, yeah, you can apply operations, mathematical operations on them. For example, additions, subtractions, and multiplications, and also division. So when you add, subtract, and multiply integers, they will always result in an int or integer type of result. However, there's an exception to this, where if you divide between integers, it will always result in a floating point value. Because let's face it, if you divide two integers, there's a very huge possibility that you'll end up with a floating point value, which is a number with several decimal points, right? So for example, let's run this and see how this goes. So to comment out, I would highly recommend using the control and the /. Can I do this here? I can, okay. Or else, if you're lazy to do this, just go to the front, to the first part of the expression and just put a hashtag. It serves the same purpose, right? To comment out, in coding, it is highly advisable for you to just comment out the lines that you are not really very keen on running. However, you'd like to keep them just because you say if you have a very long code cell and you have so many lines within the code cell, but you'd like to run only portions of the code cell. So you begin to comment out several parts of the code cell to ensure that those parts don't run. However, in this case, in integer numbers, I'd like to show you that when we assign A to the number 1 and we assign B to the number 2, and we want to see what is the resulting value of A plus B, in which we designate the result of the addition of A and B as C, right? Just doing this is not enough. You would have to write this line here, print C, in order for you to find what is the value of C, right? So let's run this, and indeed it is 3. 1 plus 2 is 3. So in order for us to probably test out the code, you may benefit from changing the values just to make sure that the code runs correctly. So when I change A to 7 and B to 4, the resulting C is actually 11. So yeah, feel free to test out your code with different values just to make sure that it works well. Okay. Hello. What is this? Okay, so floating point numbers. Floating point numbers, like I said, this data type is used to represent real numbers, and it can be specified using a decimal point or using scientific notation. So floating point numbers, in Python are called floats. So as you can see here, A, B, and C, you have a floating point number, right? But then these are specified using scientific notation, right? So for example, if you're not too keen on writing 240,000, right, but then you'd like to do it in scientific notion, let's run this. Okay, so when we print A, 240,000, and we print what is the type of A, so Python classifies A, this floating point number, as a float, right? And when we divide C with B, when you divide C with B, you can find that actually it results in this number, 19,441. Okay, so you can see how powerful Python is, but just by writing out print and applying certain things on it, like to find out the type, to apply certain mathematical operations between our variables is also very very simple. You might find that actually the operation is contained within the print statement, so that's totally permissible as well. If you want to minimize the number of lines, you can totally do this. Okay, so I guess this is the actual example. This was, I think I made several examples. So here, this is a floating point, 1.0, okay. This is another floating point, which we have 12.345, and then this is another floating point specified with scientific notation. So this is the one with scientific notation. This is just a normal floating point, right? And I think I showed you this one previously. The function type retrieves the data type of a certain object within the code, but it doesn't print the output. See? When we are asking Python for the type of A here, because our A here is 1.0, this is a slightly different variation from our previous code block, right? So in this code block, our A is actually 1.0. So when we ask for the printout of the type of A, it shows you it's a float. Notice what happens if I eliminate the 0.0 and just run this again. It shows you the class changes to int, right? Because we don't have any decimal points, Python automatically recognizes this as an integer, right? So for you to allow it to be recognized as a floating point, add a decimal point, okay? So yeah, I just threw this in for fun because I wanted to show you also that you can indeed print out a statement with a given number, right? However, you need to convert the number to a string first, right? So here I've shown you in this final line here, I'd like to print a statement, I love you 3000, okay? So the first part of the printout shows you I love you with double quotation marks, and then I take D, which is defined as 3000, and then I changed it to a string, right? So I love you 3000. What happens if I just put D, what happens? It will cause an error because we can only concatenate. Concatenate is a fancy way of saying we're combining two parts of the data together, right? So when we are combining two parts of the data together, make sure when you're combining a string with a number, change the number into a string first. So you can do this by using the str, and then you can import the data inside of D. So this will change the D equals to 3000 into a string by doing this. Okay. So make sure that your parentheses are lined up. So let's run this again. Okay. So voila. You get I love you 3000. Okay. So next is Boolean values. So Boolean values are like switches. They can be either true or false. So these are for things that can have two outcomes, right? True or false. It cannot be and. right? It's either true or false. So this is a logical statement that probably you'll be seeing in the other chapters. But for this chapter, we'll just keep it simple. Okay, so we have A, which is true, and B equals to false. This is useful when we are specifying conditions in our code. You know, for example, when we are learning about for loops or if else, you need to find out whether the statement is true or false. Okay, when you apply the logic on the code that you write, right, it's going to run only a portion of your code when certain logical conditions are met, right? So, for example, when the condition is true, then you'll run a piece of code. However, if it's false, then you will run another piece of code, right? So, probably you'll be able to see it clearly when we are going through another example, okay? So, here I just like to show you that if we say A is true and B is false, and then we try to print out the type A is true, it will return back class is boolean. Let's change this. What if I change the type into B, right? It still shows you boolean because false is a boolean type value and true is a boolean value as well, right? Okay, so strings. This is where we will have a lot of fun, right? Strings are necessary because they are sequences of characters and are used to represent text. So this is a very huge part of programming because, well, when dealing with users of your program, you would have to communicate with the users through text, right? Where the user starts, how they input information, and what is the output of the program when they have finished with the input of their value, right? All of these are conveyed through text or strings. So we can open and close a string by using either like I said previously, by the double quotation or the single quotation marks or the double quotation marks. I know this is quite small, but then it's actually a pair of single quotation marks, and this is a pair of double quotation marks. Okay, if we want to use one of the characters inside the string, simply add a backslash before the character that we want to insert the string. So, like for example, many months later, you would see that I actually took the time to import a very nice sequence from SpongeBob SquarePants, right? Just to keep it light. Okay, so I have 4 strings here. Many months later, right? The quick brown fox jumps over the lazy dog. You would see that if we printed it out, right? See, when we run this, we have no problem with single quotation marks, right? As we can see here, quick brown fox. However, when we deal with double quotation marks, you would have to use the backslash. Yes, you'd have to use the backslash with the double quotation marks because it will cause some confusion when you're dealing with the string here. Like we have the opening double quotation marks and the closing double quotation marks. However, if you don't use the backslash here, Python is going to read it differently and then it's going to call up or throw up an error. So you wouldn't want that. So I would highly recommend if you insist on using double quotation marks, please use the backslash, okay, in conjunction with the double quotation marks, and see that the printout is flawless. If I delete this, obviously it will throw up an error. You want to see? Right, so you can see that now if I delete the backslash, it recognizes this as the string and this one is the second string, but Let's just run this. Then the word over in between these two recognized strings is not recognized as a real input, and it says invalid syntax, which means the way that we write the code is wrong, so you would have to put in the backslash just to make things run as smoothly as possible. See? Okay, you might notice that with every code block I have like this, right? These are actually the expected outcomes of your code, which is why I printed it out. See? Sorry, which is why I commented it out. So that when you run this and this doesn't show underneath, right? You can make a reference that these 4 lines which has the hashtags in front, these are the expected outcomes of this particular code block. You can see this in other code blocks as well. Okay. So as we can see in line 4, it's possible to use a single quotation mark character inside a string. Like I said just now, however, if the string has been specified using double quotation marks, yeah, we need to use a backslash in order for Python to recognize it as a legitimate double quotation mark inside of a given string. Okay. So let's move on to string concatenation and formatting part 1. Python lets the user concatenate or combine strings using the plus sign, which is an operation that we'll be using a lot throughout our textbook. Okay, so in line 4 of the code, if the following code in line 4 of code of the following code cell, we see another powerful feature, which is string formatting. Yeah, so in this string formatting, so apparently I have Captain America and Wonder Woman, so let's just type in these things. Captain America, Captain, and then make sure you leave a space after that. America. Sorry for the unintended what do you say, typing errors, because this keyboard is a little bit cramped, so please bear with me. So the second one is actually Wonder Woman. Wonder Woman. So you might be wondering why I left a space after Captain. As I run this, Captain America, let's just print A and print C. You'd find that when we concatenate or when we combine 2 strings together, Python doesn't necessarily recognize a need for us to add another space before combining these 2 strings. Watch what happens if I combine 2 strings without any space between them. Let's see. See? It joins together with no space in between. So it's highly advisable for you to either introduce a space before after the first word, or you introduce a space before the second word, right? So in both cases, you can either introduce the space after the first word or before the second word. It will result in the same, yeah, it has the same result. See, Captain America and Wonder Woman. So the result, okay, the thing that I'd like to show you is actually something called string formatting with the dot format method. You can see here dot format, right? With the dot format method, Python lets us insert variables within a string and inside the place specified by the numbers between the curly brackets. Sorry, I know it's not by the way Python, it's between, right? So numbers between the curly brackets. Yeah, it seems that with a generational gap like ours, your short form and my short form might be different. So please bear with me. Excuse me. So the dot format method we can see here. So the result of 2 plus 2 is 4. So it doesn't really explicitly mention that the result is 4. However, when you print B, Python is going to automatically calculate it for you, so it becomes 4, right? In our head, we know it's 4, but then you see later when we run the code, it is indeed 4. How do we know this? We use the dot format, and in the round brackets, we insert the variable b that we would want to insert inside of our string, and then you would find that actually this dot format with the variable inside, it corresponds to this curly bracket 0. So this curly bracket 0 is actually referring to our first index 0, which is the first data that we pass into the format. So to show you what is index 0, index 1. Index 0 is the first data that we find, and then index 1 is actually the second data that we find inside a given iteration. Okay, so like for example here, the second one, I'd like to show you how powerful this dot format syntax is. You can see that print when we show here my favorite characters are 0 and 1, are curly brackets 0 and 1. Curly bracket 0 and curly bracket 1, right? And then we use the dot format. So you can see that the dot format can be used for both numbers and also for string, right? So we have format A, comma C. So this corresponds to, so this curly bracket 0 corresponds to A, which is Captain America. Okay. And then we have the curly bracket 1, which is format C, which corresponds to Wonder Woman. Okay. So you can see here when we run the code that my favorite characters are Captain America and Wonder Woman. Notice I didn't write Captain America and Wonder Woman. Instead, I pointed it out by defining A and C, which is our the variables that we declared earlier. And then you can see that the concatenation or the combination between two strings have been processed before it is displayed here. Okay, so like format B, you can see that applying the same principle, we can also use this again and again. My name is Wonder Woman, curly bracket 0, and format C, and again print I love you 3000, but then this time around we use the dot format D. Remember earlier that we used I love you 3000, but then we changed D into a string by using there's this command that I use, string in round brackets D, right? So you can do this also. It's why you can either use the string D, which entails you to convert the integer into a string. However, using the dot formatting, string formatting, right, you can also do this without any conversion. So the D remains as a 3000, which is an integer, but then the printout shows you that it takes numbers or floats or concatenated strings, and it can give you the printout of a string flawlessly this way. Okay, so I ran this earlier, and I'm very happy to report that actually the output gives us no errors, so that's cool. Okay, so thanks for sticking with me. This is the 45-minute mark, so I hope you're still with me. I think we are almost at halfway point, but yeah, please bear with me. We do have a few more code blocks to go through, so stay tuned. If you feel like you need some break, you can pause this video here, take a break, and then come back refreshed. Okay, on my part, I'll just go on because this is a recording. Okay, so strings, concatenation formatting part 2, right? So actually we did touch this in part 1 earlier, because we have two parts here. So you have format A, comma C. So we have two types of variables here that we've managed to combine in one singular string. So basically in this code block, we also did the same. However, we are doing it with three variables. So we have A, which is an integer, B, which is a float, and C, which is a string. FKJ, Faculty of Engineering. Faculty, could you return, right? That's us. So using the same syntax that we learned earlier, right? We are making a printout that A is equal to 12, B equal to 3.5, and C equal to FKJ, right? So in this magical line here, line number 4, we have managed to combine three types of data types into one string, and it's a beauty. Actually, this, well, yeah, for coders, it's a thing of beauty, because where else can you combine integer, float, and string within a string and it doesn't throw up any errors? Yeah, only in Python, and also to a certain extension, Julia, which is, well, quickly becoming my favorite language to use these days. But then, yeah, it's okay. We'll just focus on Python instead. Don't worry. Okay, so like I said, by the same convention, you have the curly braces 0, which corresponds to A, which is 12. You have curly braces 1, which corresponds to B, which is 3.5. And curly braces curly braces 2, which corresponds to FKJ. So format A, B, C follows 0, 1, and 2, right? So it's actually corresponding to one another. Because it depends on the index numbers, right? A corresponds to 0, B equals to B, 1 corresponds to B, and 2 corresponds to C. So when we run this, you would find that 12, 3.5, and C equals to FKJ. What happens if I change the order? Would it be the same, or would it be different, right? See? So we would find that actually the index positions remain the same, but then you can actually change the order of you calling the data. So when you correspond B, when you call B equals to curly braces 1, but this curly brace 1 is corresponding to C, so now you'd have the FKJ, which is C, is being placed in position on the second position, or index number 1 instead. Okay, so in terms of Python syntax, this is correct. However, when you read the sentence, the printout sentence, right? This is not correct, right? Because we know earlier that we declared b equals to 3.5 and c equals to fkj. So please be careful what type of data that you're associating the index numbers with, right? So 0, curly braces 0 is a, so that's correct, it's 12. Curly braces 1 is b, which is 3.5, and curly braces 2 is c, which is fkj. So be careful when you're writing it out, okay? Okay, so next we are going into string formatting, which uses the percentage sign, okay? So this time the positions in the string where a and b need to be inserted are identified by %.2f and %d. What do these mean, okay? So the letter f, it specifies a floating point number, right? And the letter d specifies an integer number. Okay, so let's see. My pointer last semester was %.2f. So for example, you did quite well, 3.67. So it's like borderline A minus. Okay, so here what it shows you is actually %.2f is actually a floating point number with 2 decimal points, hence the dot 2. %.2 means 0.2 means it's actually a 2 decimal places floating point number, right? And then when you specify this, when the string closes with the corresponding double quotation marks, don't forget to add this, which is a percentage, and then you have a parentheses, round brackets. So in the round brackets, point to the variable name that you'd like to display inside this string, right? So in this case, the %.2f is referring to %a, which is 3.67 in this case. Okay, it's invalid syntax because I haven't really mentioned what is the value of b previously. Okay, so also my lunch cost me ringgit Malaysia %.2f. Okay, so for example, probably I would want to get something from maybe McDonald's, eh? So 12 ringgit, 50 cents. This is an arbitrary number. Arbitrary means it can be anything you like, right? Maybe you've had lunch in a hotel and it cost you 50 ringgit. Maybe you've had lunch in a simple stall, so it costs you 5 ringgit. So do whatever you like and put it inside. If you're from, say, not from Malaysia and you want to change this, maybe into yuan or maybe into real, go ahead, change it, I don't mind. But be wary about the decimal points, %.2, because most of the currencies all over the world, it uses 2 decimal points. Although the decimal point can change between countries. I've heard that Europeans use the comma instead of a dot here, right? Or a decimal. Okay, so let's run this. Okay, so I run this and it shows here my pointer last semester was 3.67 and my lunch cost me 12 ringgit 50 cents. Okay, so in both instances you need to specify %.2f, which means it's a floating number with 2 decimal points, and you need to specify the percentage. Is it a or b or any other variable that you'd like to import inside of your string. Okay, so that's finished. I'm at the 55-minute mark. Okay, so let's move on. Lists, right? So this is, I made a fun list. Like previously, yeah, in class, I made a list of, Justice League characters. So it'll be the same. Probably it'll help you with your learning because, well, probably, yeah, superhero characters are a little bit more easier to remember rather than, a bunch of numbers or a bunch of, structural objects, right? So here goes. Lists are used to represent a sequence of objects. If, say, you've used other programming languages before, you can think of lists as arrays in which we can store any type of data that we want. For example, integers, floating point numbers, strings. Inside the list, you have a smaller list or embedded lists, nested lists, right? And so on and so forth. Okay? However, if this is your first time programming, it's okay. You can think of lists as vectors or matrices, okay? Just like the ones that you see inside of calculus 2, right? So the list depends on the dimension of the list itself, right? You may have like a 2 by 2 or a 3 by 3 matrix, so on and so forth, okay? But that one we will only cover in our subsequent chapters. Probably not today. Well, actually, we do. We won't go too much in depth, but then I'm going to show you an example of a matrix here. Yep. But then it doesn't really show very nicely. Probably later during NumPy arrays or in data frames that you'll be able to see very nice looking matrices. My apologies. Okay. So anyway, so lists are a collection of objects specified using square brackets and commas. So please remember, okay, lists are indeed defined by square brackets. Okay. Later on, you will see curly brackets and also run brackets. So each type of these brackets are representing different types of data types or data structures. Different types of data structures. And inside of the data structures, you have multiple types of data. So for example, for lists, these are defined using square brackets, right? So for example, I have my list 1 and I have a list of integers from 1 to 3 and 4, okay? So you can also see that we can nest lists one inside another to create multi-dimensional data structures, right? So this is actually what we see in line 1, 2, 3. So this is where you see nested lists. So it's like a list inside a list, which is why it's called nested list, because it's a list nested inside a larger list. Okay. So in list 1, this is a list of integers, and then in list 2, I'd like to show you that actually in list 2 we have a mix of a string, an integer, and also a float, right? And in addition to these different types of data being defined as one list, we can also insert the previous list, which is my list 1, right? So when we define my list 1 and we insert into my list 2, let's just run this real quick. What happens? So if the first line, which consists of my list 1, which is the list of integers, and then you would find that if we print out my list 2, it gives you a readout of the string, dark side, and then you have the integer and you have the float, and then suddenly our good friend here, my list 1, it appears as a nested list, which is a list inside of a larger list, right? So remember this when you're writing down your answers. If a list is nested, right, you would have to show that it has its own set of square brackets too, or else it'll be wrong. Okay, so last but not least, you can see that the matrix MIT, we have 3 lists inside of a large list, which is called mat, right? So this matrix, so you have the first line 1 2 3 4, second line 5 6 7 8, and the third line 9 10 11 12. Okay, sorry, when we print out mat, so it's going to look like this. We do have other types of formatting, ways to format, but we won't touch it here today. It's okay. Please join me in my other Python sessions where we will find ways to format these matrix that we define, so that it looks nicer than just this. This looks like a nested list, which looks very, very rudimentary, very basic, but yeah, that's what you need at first, and we can format it later, right? So to continue to access a value within a list, we use the square brackets to specify the index of the element that we wish to retrieve. Okay, in Python, like I mentioned previously, lists are indexed starting from 0. So the list element number 1 is actually index 0. See, like I mentioned previously, lists are indexed starting from 0. So the first element is in position 0, the second is in position 1, and so on. Please, please, please remember this distinction. What is the difference between the element and the index? So when the index is 0, it refers to the first element, and then when the index is 1, the element is the second element, and so on and so forth. Okay. If we have a previously defined list and we wish to change one of its values, simply assign the new value to the position we want, like in line 3, right? So if a list is multidimensional, for example, line 5, which is B, right? To access a specific position, we need to use 2 sets of square brackets, which is in line 6. So line 1, 2, 3, 4, 5, right? Oh, sorry. This is line 3, yeah. And then the multidimensional list is line 5, right? 1, 2, 3, 4, 5. So this is the multidimensional list, and line number 6 is actually the access to a specific position that we need. Okay, so in the continued list, okay, so we have a list here which contains 4 elements of integers, right? So A, previously we don't have list called A, so our list A is a new list, and it contains 2, 4, 16, 32. Okay, so when we print A2, right, it's going to show you the third element, because it's actually at index 2. This is the first element, which is index 0, second element, which is index 1, and the third element, which is A2, right, because it's the index 2. Let's see how it comes out, right? So let me just comment out everything, see how it runs. Okay, so I didn't even print A, but when I print A2, probably I should make this smaller. Yeah. Okay, so when I print A2, which is list A but at index 2, it shows us the third element, right, which is 16. So we did that correctly. So say I want to change A square brackets 1. Okay, so A square brackets 1 is actually referring to the second index. 0, index 0 is 2, index 1 is 4. So when I change 4 to rose, okay, you can just use any string you want. This happens, yeah, this just happens to be like a Blackpink member, Rose. Okay, so when I do this, at the index position 1, and I name it Rose, okay, when I print it out, you would see that actually it will become, I will predict 2 Rose 16 and 32. Let's run this. Yes. So the reason why Rose changes from 4 to Rose is because I specified in index number 1, which is the second position, I wanted the second element to be changed with a specific string. In this case, it's rose. Sorry, rose. Rose, yeah. Because of the E, the French E, apparently. Okay, so that's that. Okay, so let's comment this out and let us remove the comment lines here. So the second one is we have a multi-dimensional list. When we see this is actually a 2x2 multi-dimensional list, right? So to prove a point, let's just print out B. Print B. What happens? When we run this, what happens? Okay, so it's going to show you 3, 6, 9, and 12. Okay, so by specifying print B index 1, okay, we are going to extract the element or the specific position, right, of a certain element inside of this multidimensional list. Okay, B index 1 means we are going to, why is it 12? It's because B1 actually refers to the to list at index 1, which is the second list, and the other index 1 is actually referring to the second position inside the list. Okay, second element inside the second list. So B11 refers to 12. Okay, what happens if I print out B01? Okay, why is it 6? It's because B0 refers to the first list, right? The first element inside our list. So the first element inside our nested list is the first list. So B0 refers to list at index position 0, and index 1 here, it refers to the second element inside of the first list. So index 0 and index 1 becomes 6, right? And to reiterate, B square brackets 1 refers to B square bracket 1 refers to the second list, which is a list at index 1, and index 1 refers to the second element inside of the second list. So therefore, to access a specific position, we need two sets of square brackets, and then, yeah, inside the square brackets, we need to identify the corresponding index values. Okay? So I hope, so okay, say we want 3, right? So you would have to change that into B00 because it's the first list and it's the first element, right? Which is why it's number 3. Okay. Another example would be, say you want number 9 instead. Just now we saw example for 6 and 12 and 3, right? So now what if we want number 9 instead, right? So we specify 1, B10, okay? See, it shows number 9. Why? Because B1, the first index number, refers to the nested list. Is it the first nested list or the second nested list? Index number 1 tells us it's the second list. And the second index number 0 shows us inside the second nested list, you would want to zero in on the first element, which is why we have number 9 here. Okay, so feel free to experiment what you like. So you can show B00 is 3, B01 is 6, B10 is 9, and B11 is 12. 3, 6, 9, 12. See? Simple. Hopefully this will make you understand the index position a little bit better. Okay, 3, 6, 9, 12. Okay, so this is where the fun begins. We have lists, and in this list we have the Justice League list, right? To access an object's built-in functions, in Python, we use the dot followed by the name of the method. So in this list method, we have several types of built-in functions. So we have append, we have insert, we have remove, we have pop, we have extend, and we have index. Right, so here is where we code together, because I've successfully changed some of these things. Alright, so in my initial list of Justice League, you have Batman, Superman, Wonder Woman, Aquaman, and Lois Lane. Well, obviously Lois Lane doesn't really this is an homage to the new Snyder cut as opposed to the previous Avengers. So sorry, not Avengers, as opposed to the previous Justice League. My goodness. Okay, and then you can see that actually, yeah, I just like to show you that in our list, for a given list, we can actually append. Append means you are inserting a new element specified inside the dot append. So someone new inside of the new Justice League is actually Darkseid, right? And then here append 0, right? Curly braces 0, format JL, which means that when you append, so Darkseid will appear at the very end, and then you can see so many things. Okay, let's run this. So you can see that I forgot to delete this. Not really delete, I need to comment this out. Okay, so let's just run this. Okay, you can see that. The original Justice League has Batman, Superman, Wonder Woman, Aquaman, Lois Lane. Okay, but when you append it, right, you have the original list. However, when you append Darkseid, it appears at the end, right? Okay. So say you want to insert something new. For example, Joker. Ta-da. When you have Joker, right? So insert jl.insert tool, right? What's nice about insert is actually you can specify the index position in which you want to insert this particular element here, which we have Joker, right? So what happens is when we insert tool, it means it will come in at the third position because yeah. So Batman is index 0, Superman is index 1, Wonder Woman is index 3, 2, right? However, when we put in Joker, right, you will see that actually Joker will come before Wonder Woman. Why? Because when we insert at position 2, Joker is going to come between Superman and Wonder Woman and is going to push Wonder Woman one index further, one index number further. So to prove this, we can see, okay, so when I insert Joker at position 2, sorry, index number 2, you can see that first we have Batman, Superman, then Joker, right? Like I said, it's going to be at the third position. Why? Because it's index 2. We have made the calculation just now. Well, not really calculation, we predicted where it would end up, right? So you can see here that Joker indeed appears between Superman and Wonder Woman, and Wonder Woman is pushed to position index number 3, which is number 4. Okay, so now the list is getting a little bit long, so let us remove something. Yeah, I know that Lois Lane still is in the movie, but apparently she has a reduced appearance in this cut. So when we remove Lois Lane, what happens? When we remove Lois Lane, you would see that Batman, Superman, Joker, Wonder Woman, you would find that Lois Lane, who used to be in between Aquaman and Darkseid, is no longer in this list because she has been removed. Sorry, Lois. Okay, now we have another one here. It's called jl.pop, right? So jl.pop, it's going to allow you to remove an element inside of the list based on the index number. So the index number here that we have is number 1, right? So let's see. Oh, sorry. So you can find here that actually, wait. When we pop number 1, you would find that actually inside the list, we would remove the element in index number 1. So index number 1 is actually 0 and 1. So index number 1 is Superman. You would find that actually when we run the code for pop, you would see that in the pop list, Superman has been removed or popped, so to speak, because we remove the element, the index number 1, which is element number 2. Okay, so another type of function that we have here is the extend, right? So in extend, extend attaches the iterable object specified at the end of the list. Okay, so the extend, you can actually add more than just one element. So in this case, actually, I'd like to extend the Justice League list to include two more things, in which actually this is kind of my favorite part of the new card, which is Black Suit, Superman, and also the Flash. Yep. So let's see what happens if we use the jl.extend. See, you can find that actually the extend function allows us to add, say, numbers, list, or string. Yeah, but in this case we are adding a list that contains two strings, Black Suit Superman and also the Flash. So you would find that actually the extend is adding these elements towards the end, right? So Black Suit Superman and the Flash are found at the very end of the list. And last but not least, you can actually find the index number of a certain member of the Justice League. So say you want to find Batman and you want to see where he is in the index number. What is the index number for Batman? Batman. We run this and you'd find that the index is 0. Okay, say we want Joker, right? And we can see that Joker is actually at the second position, so the index that it will return is actually index 1. Oh, sorry. So let us just see Joker. Run this and it gives you 1. Okay, say we want, okay, so last example, Darkseid. So Darkseid is 0, 1, 2, 3, 4. So you would see that the Darkseid is going to return number 4, right? Yes. So there it is. Voila. So that's fun with Justice League. Okay. So I'm not going to bore you with the song list. It's okay. I think we did this in the tutorial previously. So I think I'll just skip this very quickly. You can refer to our previous tutorial just as a refresher. Okay. Right. So next we will recap the various functions that we have. So we have append, we've done this. We didn't do clear because I'm not going to delete all of the elements from the list. You only do this if you want to start off with a fresh list. Okay, we didn't do this previously, but it's okay. Right, a copy of the list is when you make a copy of the original list and you'd like to do some changes to it, but you don't want to destroy the original list, so you copy it first. Okay, so count value returns the number of elements equal to value. It's okay. We have extend, so we've done extend, we've done index. Did we do insert? Yes, insert position and element, because we did the Joker just now, right? We did pop just now with the position, so we removed Superman just now because Superman was actually in index 1. So pop and position number 1, for example. So removes the element in the position specified by position. If the position is not specified, it removes the very last element of the list. So if you keep the pop function, but you did not specify any position, it's going to delete the last thing on your list, so it's okay. You can remove. Did we remove? Yeah, we removed a certain element, which is Lois Lane, for example, right? We can also reverse the list. And we can also sort the list. But reverse sort and also clear and copy we didn't do. But feel free to experiment this on your own. I think we covered quite a lot today in lists, right? Okay, so to continue, dictionaries. So remember just now lists were defined with square brackets. Now we have dictionaries, which are similar to lists, except that they are unordered. And each element in a dictionary has a key associated to it that acts like its name. So, for example, I'm going to go back to our civil engineering roots, and then I'm going to give you an example of a dictionary that is, civil engineering based. So, for example, my dictionary is actually a beam, a steel beam to be precise. So, this is an example of a steel beam inside the specification of a Euro code. So we have two parts of a dictionary here. So first of all, a dictionary is defined with curly brackets. So not only does index numbers use curly brackets, dictionaries also use curly brackets as well. So at the start of a dictionary and at the end of a dictionary, you'd have to use curly brackets, right? Okay. So in a dictionary, you would have something called a key, right? So this key, for example, here is an object. Our key name is object, and the corresponding value of a given key is given after the colon here, right? So for example, here we have 5 types of keys. For a steel beam of a type IPE 120, you have 5 keys. So you have the object, you have the material type, the height, and the width or breadth, right? So when we want to access one of the values of the dictionary, we need to use its key. So for example, you have my dictionary, which is defined this way. So you have 5 keys and their corresponding 5 values. So the object is a beam and the material is steel, and it has a type of IPE 120 with a height of 120 and a breadth of 64. Okay, so they have similar built-in methods as lists. So let me save this very quickly. So to call out a dictionary and its key, right? Print my dictionary and you specify the key, which is material. Let's run this. You would find that the material is steel. So when we specify the key, it's going to give you the value of the given key, which is material. Yeah. So the given key is material and is giving a value called steel. Okay, say let us specify the second, let's call out the second element inside the my dictionary, which is type. Right, so when you have a type, so it's going to show on IP 120, right? Because we called the key, it's called type. It's going to give you the value of IP 120. Last but not least, let us check the height of the steel beam, which is H. So it's going to give us a value of 120, right? If you want to test out the other type of keys, so you can have B, it's going to give you 64, right? And we can even say object. And let's run this. Yes. So inside the dictionary, you can call any type of keys on the left side. And Python is going to show you the values with the corresponding keys, which is on the right side of the colon. So on the left is the key, on the right is the values. Okay. So that's the dictionary and it uses curly brackets. Lists use square brackets. So we have, last but not the very least, are tuples. So tuples are a collection of objects that are ordered and unchangeable, cannot be changed, just like blockchain, just like Bitcoin. You cannot change the order, right? It's what you call unmutable, immutable, something. Yeah. So since you can't change it, and it's not like a list, you can order the list, you can sort it out, but tuples cannot be changed. This means that after we create a tuple, we won't be able to modify its values in any way. So these are important for stuff like won't change, for example, probably the multiplication table, or probably the catalog from which it has been derived from the Eurocode, perhaps, right? So these things, they do not change with time, and therefore it's safe for you to save them in terms of tuples. So tuples are specified like lists, except that they use round brackets instead of curly brackets, right? Or in this case, lists are with square brackets, sorry. So curly brackets are dictionaries. The two methods that can be used on a tuple are count and index. Do you remember what are the types of methods that we can apply onto lists? So many, right? We have pop, we have extend, we have remove, we have insert, we have append. However, with tuples we have count and index only. So the first one, count, it counts the number of elements within the tuple that correspond to the argument passed. The second one, index, it returns the position of the first occurrence. So index is very much like the index for the list that we learned just now. For example, if we look at the index of dark side, it's number 4. But then when we change, we want to find the index number for Batman is number 1, right? Because it's the first. Sorry, index number 0 because it's the first element. I'm sorry. So yeah, index number 1 is a joker because it's the second one. Yep. So again, for tuples you have count and index, and we have to ask ourselves, what is the point of tuples if Python already has lists? So the very important use for tuples is that it's mostly used when we return values from functions and can be unpacked into separate variables. We will use tuples and lists extensively in functions. So functions are probably something that you will learn. Yeah, we will learn about functions later, but it is very important for you to know that tuples and lists are very important parts of a function. Okay, for example, first we have my tuple, and in this tuple we have 1, 2, 3. So we have like 3 integers here, and then we have 1 string here, and then we have a number of integers as well at the back. Alright, so let's print out my tuple first. So you have 1, 2, 3, apple, and 5, 2, 3. Okay, to demonstrate count, right, so we can see here my tuple count.count2. What this tells Python is that we are asking to Python to go through my tuple and to see how many instances of the number 2 that we have inside of this tuple. Okay, so let's run this, and Python correctly gives us the value that, yeah, inside my tuple, the element 2 appears 2 times, right? So what about yeah, that's count 2, right? And then print my tuple.index 5. So it's going to ask, hey Python, can you tell me what is index number 5? It's not number 4. Oh, it's number 4. So index number 5 ¿Dónde estás? What? Okay. Index number 5 is number 4. Oh, because there's no index 6, 1, 2, 3, 4, 5, 6, 7. So there is no index 6, but index 5. Okay, so when we run this line, my tuple.index 5, so it's going to return the index number 4. Why? It's because number 5 is at index 0, index 1, index 2, index 3, and index number 4, which is why it shows you number 4. Let us ask Python, what is the index for apple? It's number 3. Why? Because index number 0 is number 1, index number 1 is position 2, index number 2 is position 3, position 4 is apple, so it's going to return, and index number 3 because it's at element number 4, so it will return the index number 3. Okay, so last but not least, let's show what is the index for number 1. It's going to return 0. Yep, because it's the first element that we see in this tuple. So there you have it, folks. You have count and index. Okay, so let me just stop here, and then I'll continue on with condition statements, and yeah, we will be delving more into the use of logic in conjunction with the data types that we have. The second part is going to be a bit long, so I do hope that even though we stop here, you will look at the second video, and I'll see you at the second video. Thanks so much, guys. See you soon. Bye.